this will be a really quick practice with giving compounds. Can you pick out what of the different types of solids these guys are? So if you haven't already done it, pause it right here and figure out what type of solid each of these chemicals is, and I'll go through the answers in about 3 seconds. Now when I look at this, I always start off here with my network solids. So network solids are pretty easy to pick out. Okay, there's only a few of them, so SiO2, so we've got that one, and carbon as graphite. The other example would be carbon as diamond. Another one I think is pretty easy to do is pick out the metals. So we look down the list, here's gold, so gold is going to be there. Calcium, okay, not quite so obvious, but remember that everything on the left side of the periodic table except for hydrogen counts as a metal. Now, ionic compounds, okay, that shouldn't be too tough. So ionic compounds, we're looking for positive and negative ions. So here we have potassium and bromide, and anything else, everything else looks good. Okay, be careful when you see HCl, it looks like it might be an ionic compound, but remember hydrogen and chlorine are both nonmetals, so that is not going to be an ionic compound. Now we're going to go to the molecular. So these are things that, all the ones here are ones that are not molecules, they're extended crystals. And I should knock these two off, we're finished with those. And all the rest means all the rest of these are actually molecules. So let's pick a different color. Now for a molecule, we have to decide, is it a polar molecule or non-polar molecule? So all the non-polar molecules can be held together with London forces. So we can look through these and say, okay, here's krypton. Okay, krypton is a noble gas. It comes as single little particles, so those are going to count as non-polar molecules. When we see CO2, okay, CO2, we've seen that before. It's, C between two O's. That's a non-polar molecule. And whenever you see carbon-hydrogen compounds, those are non-polar molecules. The carbon and hydrogen are very close in their electronegativities, so it doesn't even matter what the shape is, that those are going to be non-polar molecules. Then I would go ahead and look at hydrogen bonding. So molecules that have nitrogen with hydrogen, okay, fluorine with hydrogen, or oxygen with hydrogen, those are going to be hydrogen bonding. So here we have our NH3 and H2O, and then the only one we have left is HCl, and we can see, well, HCl must be dipole-dipole. It's a polar molecule, and it's going to be dipole-dipole. And that's how we did this whole chart.